So welcome back to our trigonometry lessons, and today we're going to be looking at some more questions involving sine and cos in the same equation. Yesterday, in the last lesson, we were looking at types where we had sine and cos operating on the same angle, and because of that we could divide both sides to get tan. So here we had sine of 2 theta plus 12 degrees, and we had cos of 2 theta plus 12 degrees. And when we divided that, we got tan, and that then became much simpler to solve. Today we're going to look at something that's similar but different. We have sine and cos, but acting on different angles. Now, before we do this question, we're going to do a much simpler one on the side here. All right, suppose we had sine theta is equal to cos of, say, 80 degrees, right? Now, the first thing we could do is we could change this into sine using our co-ratios. Remember that sine of 90 minus an angle is the same as cos of that angle. So, in other words, cos of 80 is the same as sine of 90 minus 80. Right, and 90 minus 80 is just the same as 10. Okay, so now we've got sine theta is sine of 10. Okay, now, right, and that is a whole lot better. Okay, one obvious answer here is that theta could be 10 degrees. Or any repeat of 10. When I say a repeat of 10, in other words, if we add 360 or minus 360. Okay, now the other answer, there's a whole family of answers that we don't have at the moment that we're missing. And that is because there is another place where sine has the same value as sine of 10. And let's just picture our little cross diagram. Where else is sine positive? Well, it's positive in quadrants 1 and 2. So there's another angle where sine takes on the same value as it takes on at 10, and that's 180 minus 10. So the other possibility here is that theta could be 180 minus 10. Obviously 170, but I'm just going to write it as 180 minus 10 plus 360k. Okay, with k an element of z. So if we've got sine and cos in the same equation, but they are operating on different angles, then what we can do is we can change one of those ratios into the other one, and I think it's maybe easier just to change cos into sine, all right? But we can also change cos into sine or sine into cos, all right? And then, once we've got the same ratio on each side, if it's sine, then we would say that the two angles are equal, or the one is 180 minus the other angle. Okay, we're going to do this one. This time, in fact, what I'm going to do, we're going to change this one to cos of 90 minus theta. So sine of theta is exactly the same as cos of 90 minus theta. And so now we've got cos of 90 minus theta is cos of 3 theta plus 20. Now there are two possibilities. Either 90 minus theta is 3 theta plus 20, right, plus 360k. In other words, the two are equal one another. Or, and again, I can draw a little picture of a cast diagram. The other place where cos is the same value as it is at a given angle is 360 minus. All right, we're using our cast diagram. Where's cos positive? So the other possibility here is that 90 minus theta could be 360 minus all of this stuff. Plus 360k. Okay, and so in fact we're running out of space a little bit here, but the top one becomes minus 4 theta, and here we got minus 70. So when we in fact divide through by minus 4, we get 70 over 4 minus 90k. And the bottom one is we've got a minus 3 theta, which when we add becomes a plus 2 theta on this side. And here we've got 340 minus 90 is 250. So our final answer on this one, if we simplify it all, I think and hope I'm right in saying it's going to be 250 over 2 plus 180k. Right, and for both of these, k would be an element of z. Okay, all right, so fairly interesting this, okay? But the thing to remember is, and we've summarized it for you up at the top here, if we've got sine equal to sine, then either the angles are equal with 360k added to one of them, or one of them is 180 minus the other. In other words, A is 180 minus B. If we've got cos equal to cos, then the angles are equal, or the one is the negative of the other. The negative takes us into quadrant 4. We could also go with 360 minus. And lastly, if we've got tan equal to tan, then we just take the two angles and we add 180k. Okay, so I'm going to do the next two. We're going to do the next two together, and then we're going to ask you to try. Okay, so this one here, sine theta equals sine 10. We kind of a step in with this one. The one answer is that theta equals 10 plus 360k. And the other possibility is that theta is 180 minus 10 plus 360k. Both with k an element of z. Okay, now the next one is slightly more interesting because we've got, well, this time we got cos equals cos, all right? So it's not actually much more interesting. Let's put them equal to one another. So theta plus 20 is 50 degrees plus 360k, all right? Or theta plus 20, now we've got a choice. We can either go minus 50, which gets us into quadrant 4, or we can go 360 minus 50, which also gets us into quadrant 4. Both of these are k element of z. Don't forget to write that down. Okay, and let's just see what these simplify to. This one simplifies to theta is 30 degrees plus 360k. And this one simplifies to, we've got 360 minus 50, that's 310. Take away 20, we've got 290 plus 360k. This is the general solution to that equation. Okay, and let's just, because we can, let's just test an answer or two using a calculator. Okay, so for example, if k was 10, then we would get 30 plus 3,600. We get 3,630. Let's put 3,630 into that equation, right? 3,630. So cos of 3,630 plus 20. Okay, let's see what we get. And that'll be exactly the same as if we work out the right hand side, which is cos of 50. Cos of 50 also going to be 0.642. All right, let's test one from the bottom here. 290 plus 360. Suppose k was minus 1. 290 minus 360. So we're saying cos of negative 70. So let's check this out. If we find the cos and we put negative 70 in here, and we're over here, we're looking at theta, all right? Negative 70 for plus theta. So negative 70, and then plus the 20, all right, we're going to get that same value for cos of 50. There it is, it's 0.6427. Okay, so it definitely works. Let's just summarize what we've done here. When we have sine and cos in the same equation, we change one into the other with the co-ratios. And then we generate our general solution. If we've got sine equals sine, and I'm going to summarize it for us over here down the bottom. For example, if we've got sine of house equals sine of fish, the two possibilities are that house equals fish, or that house is 180 minus fish. And the reason it's 180 minus is because sine of 180 minus is the same as sine. Okay, it's because of our cast diagram. Now, to each of those, we could add 360k. That's if we've got sine equal to sine. If we've got cos equal to cos, and I'm just going to scroll just slightly up here, and I'm going to write this at the top of the next page. If we've got, for example, cos of ball, okay, equal to cos of maybe lightning, all right, then either we have ball equals lightning, or we have ball is 360 minus lightning. Okay, and again, that's because of our cast diagram there and there. All right, and again, even if it's cos, it can be plus 360k. And this one can be plus 360k. Okay, now we're gonna pause the video. Remember that if we've got tan of something equal to tan of something, really straightforward. We just put the angles equal and we add 180k. All right, pause the video and try these two at the bottom of page 127, and then we'll go over them. All right, this first one, let's leave this one as sine theta, and let's change cos of 3 theta to sine of 90 minus 3 theta. Now the one possibility is that theta is 90 minus 3 theta. The other possibility is that theta is 180 minus 90 minus 3 theta. And for each of these we must add 360k. And for each of them we must remember somewhere we must write down that k is actually an integer. Okay, right. From here it's just algebra. We add 3 theta to both sides, we get 4 theta, and when we divide through by 4, we get 90 over 4, which is 22.5 degrees, plus 90k. That's the top one. The bottom one, we've actually got 90, and then we've got a plus 3 theta. Now, when we subtract the 3 theta from both sides, we're going to get negative 2 theta, right? And when we divide, remember there's 90 here, when we divide through by negative 2, we're going to get negative 45 degrees minus 180k. And that there is our general solution for that one. Okay, right, both those two. So in other words, all of this stuff. That's our general solution. Okay, right, the next one involves tan. And tan's actually quite simple to deal with because we just need to take the two angles, make them equal, and add 180k. Let's say that again. We're just going to say 3 theta is theta plus 34 plus 180k. Don't forget, whenever we write a k, we must write down k in an element of the integers. So if we solve this, we just get 2 theta is 34 plus 180k. Divide both sides by 2, we get theta is 17 plus 90k. Right, so there's our answer. I love to test an answer, okay? I love to say, well, if theta was just, if k was 1, then we get 107. So now let's see if we put 107 into that equation. In other words, let's work out the tan of 3 lots of 107 on the one hand, and let's work out the tan of 107 plus 34. So I hope you see what I'm doing here. I've generated a solution by letting k equal 1. So if k equals 1, then one possible answer is that theta is 107. Now what we're going to do is we're going to put 107 into the left-hand side of the equation, work it out with the calculator, and we're going to put 107 into the right-hand side of the equation, work it out with the calculator. If we get the same answer, we are right. Okay, so here we go. Tan of 3 lots of 107. And we get negative 0,809. Just remember that number, negative 0,809. Okay, now let's work out the tan of 107 plus 34. We're going to get exactly that same number. There it is. Okay, all right. It's very, very cool. Okay, now what we want you to do next, before we see you next time, we want you to try these questions on the next page here. All right, this one's actually got a little error in right at the bottom right here. This should be 5 sine theta plus 11 and negative 7 cos theta plus 11. Now, just to revise what we did yesterday and what we've done today, there are two different types. If the angle is the same in both, all right, then we can divide and we can use tan. Cordway, if the angle is not the same, so have a look here. The angle is the same on both. There's a sine and a cos, same angle. We can use the tan trick. But if the angle is not the same, we cannot divide to make tan. Here, we need to change one into the other using co-ratios, using the 90 minus rule. Try this whole page of questions before we see you next time, and then we'll go over them next time. We look forward to seeing you then. Have a great day.